I would like to welcome you all in the playlist of Basic Electrical Engineering. In this video, I am going to discuss most important multiple choice questions which can be expected for various competitive examination in the area of Basic Electrical Engineering. Let's get started. Moving on to the first question, the unit of impedance is dash. As you all know that the passive elements such as resistor, then capacitor and inductor that offers a net impedance or net resistance in an AC circuit, that is known as impedance, that is denoted by the capital letter Z. The unit of impedance will be ohms. You can go ahead with the option A. Next question, unit of inductance. You know the importance of inductor. Yes, the unit of inductance will be expressed as Henry. Okay, you can go for option B. Moving on to the third question, the unit of angular frequency. You know angular frequency omega, that is given by 2 pi f, where small letter f is known as supply frequency. The unit of angular frequency is expressed in terms of radian per second. Go ahead with option C. Moving on to the question number 4. Ratio of real power to apparent power. Ratio of real power to apparent power is nothing but power factor. You have to select option B. Real power is also known as true power, or you can call it as active power. Question number 5. Unit of active power or true power. Kilowatts, kW. Please select option B. Next question is unit of reactive power. Usually reactive power is expressed in terms of kVAR or VAR. Volt ampere reactive. Please do select option C. Power factor of resistive load is, what is the value of power factor of resistive load? It will be always 1. You can call it as unity. So you have to select option A. Question number 8. Power factor of RLC series circuit. You can able to calculate by using an impedance triangle. So if you calculate the power factor, that is cos phi, that you will be getting R divided by Z, where R is the resistance and Z is the impedance. So please do select option B. Option B is the correct answer. Question number 9. Power factor of RC circuit. If you inspect the impedance triangle of RC circuit, that will be similar to RLC circuit and RL circuit. So therefore, the power factor of RC circuit also will be R by Z. Please do select option B. Question number 10. The average power consumed in an inductive and capacitive circuit. You know that average power consumed by inductive and capacitive circuit will be always equal to 0. Only resistive element will be consumed, dissipated the power. Alright, so you can select option B. Because these two elements are energy storage element. It never consumes any power. Question number 11. Dash is used to measure single phase power. Which among the meter? So please select option C, wattmeter. You know wattmeter will be having current coil and pressure coil, and also the terminals of wattmeters are M, L, C and V. M stands for mains, L stands for load, C stands for common and V stands for voltage. Question number 12. The unit of apparent power. Usually unit of apparent power is expressed in terms of kilovolt ampere, kVA. Please to select option A. Question number 13. Power consumed in an RC series circuit. So what is the value of power consumed in RC series circuit? It will be VI cos phi, where cos phi is the power factor. Cosine angle between voltage and current is known as power factor. It is expressed in terms of cos phi. Question number 14. Maximum value of power factor is. What is the maximum value of power factor? Of course, the maximum value of power factor will be 1. So you have to select option A. Question number 15. Impedance of RL circuit. So how to calculate impedance? Z is equal to square root of R square plus XL square, where XL is known as inductive reactance. You can use this equation. XL you can calculate by using the formula L into omega, where omega is known as angular frequency, L is the value of inductance. So the unit of impedance will be ohm. Then impedance of RLC series circuit. So we have 3 elements, resistor, inductor and capacitor. So how do you calculate the impedance? Yes. Suppose if the inductive reactance is greater than capacitive reactance, then you can use the formula Z is equal to square root of R square plus XL minus XC the whole square. If the capacitive reactance exceeds inductive reactance, then you can use the formula Z is equal to square root of R square plus Xc minus XL the whole square. Ultimately, the unit of impedance will be ohm. Then you can able to answer question number 17. DC motor is an example of. Please identify which is the right answer. Yes, of course, DC motor is an example of RL load. So please select option B. And if I talk about the question number 18, the incandescent lamp is an example of dash. Please select the appropriate answer. Yes, of course, incandescent lamp, it is a resistive load. So power factor of an incandescent lamp will be unity. There is no phase angle difference between voltage and current. So you can go ahead with option A. Question number 19. Identify the energy storage elements or elements. Please identify which is the right answer. Yes, of course, resistor is not an energy storage element, but inductor and capacitor both are energy storage element. Therefore, please do select option D. Option D is the correct answer. Question number 20. A pure capacitor allows a current of 10 amps to flow from 230 volt 50 Hz supply. The capacitive reactance is dash. So capacitive reactance, that means the resistance offered by the capacitive element is known as capacitive reactance. Definitely it is in the form of a resistor only. The unit of capacitive reactance will be ohm. Therefore, the voltage is given as 230, then current will be 10 ampere. So you can use the Ohm's law. So the capacitive reactance is given by 230 divided by 10. That is nothing but 23 ohm. Please do select option A. Moving forward, question number 21. The supply frequency in India is dash. So please do select the right answer. The supply frequency in India is 50 Hz. If I talk about supply frequency of United States of America, then supply frequency will be 60 Hz. But for our question, supply frequency in India is 50 Hz. Please do select option B. Moving forward, what is the voltage level at the generating stations in India? So please do find out the right answer. Yes, of course, the generating stations in India has been limited the voltage as 11 kV. Please do select option B. Question number 23. What is the voltage level at the residential building? You can directly give the answer. It will be 230 volt. Please do select option C. There will be a tolerance plus or minus 10%. 230 plus or minus 10%. You can write like that. Anyway, by looking at the question, the right answer is 230 volt, option C. Question number 24. Dash three-phase connection is suitable for high voltage and low current application. So, you know the three-phase connection. There are two methods. Either you can go ahead with a star connection or delta connection. So, regarding high voltage and low current application, you have to select it. You have to go ahead with the star connection. It is also known as Y connection. If I talk about another method, that is delta connection, that I will discuss later. However, the right answer for this question is star connection. Question number 25. Dash three-phase connection is suitable for high current and low voltage application. Yes, it is just opposite to that of star. So you have to select delta connection. Delta connection is most appropriate for high current and low voltage application. Question number 26. The voltage between two lines is known as dash. It is a line voltage. Let me explain with the help of a simple diagram. So please consider the diagram. So R, Y, B are the three lines. So voltage between R and Y, that is known as VRY. Voltage between Y and B, that is VYB. Voltage between R and B, that is called VRB. All are called line voltage. If I talk about another question, the voltage between line and neutral is known as dash. It is of course phase voltage. Let me explain with the help of a diagram. Consider a star connection. You can able to draw a neutral point, a neutral line. See, the voltage between phase 1 and neutral, or voltage between phase 2 and neutral, or voltage between phase 3 and neutral, all are called phase voltage. It is very important for three-phase connection. You should know what is the difference between line voltage and phase voltage, and line current and phase current, of course. So another simplified diagram which depicts the easy bifurcation between line voltage and phase voltage. Voltage between two lines R and Y, that is called a line voltage, where voltage between R and neutral, that is called a phase voltage. Or you can express in terms of other lines also. For example, voltage between Y and B, that is a line voltage. Or you can call voltage between B and neutral, that is another phase voltage. So try to understand in this fashion. Question number 28. In three-phase star connection, the line current will be equal to dash. In star connection, line current will always equal to phase current. So there is a table that gives the relation between line quantities and phase quantities in star connection and delta connection. It is very important. Please note down right now. Question number 29. In three-phase delta connection, line current is equal to dash. In three-phase delta connection, refer the table. If you understand the table, in three-phase delta connection, line current is equal to root 3 times phase current. Always line current greater than phase current in delta connection. So what is delta connection? So three coils, like starting of one coil is connected to ending of another coil, and there is a closed path. Such kind of connection is known as delta connection. There won't be any neutral point in case of delta connection. In case of star connection, the similar end of three coils are connected at a particular point, that is called as star point or neutral point. Hope you understood. Question number 30. In three-phase star connection, line voltage is equal to dash. Line voltage is equal to root 3 times phase voltage in case of star connection. That means line voltage always greater than phase voltage. Question number 31. In three-phase delta connection, line voltage will be equal to dash. Of course, it's phase voltage. If you study the table, that is good enough. Question number 32. Power consumed by a three-phase load is dash. You can write the power consumed in three-phase load in terms of line quantities and phase quantities. If I write the power consumed in phase quantities, you can able to write P is equal to 3 Vp IP cos phi, where Vp and Ip are called phase voltage and phase current. Or else you can write in terms of line current and line voltage. P is equal to root 3 VL cos phi, where cos phi is the power factor. Both are correct. You can write in terms of phase quantities or line quantities. It is up to you. Question number 33. The best method of measuring three-phase power. Of course, there is no doubt. Go ahead with the 2 wattmeter method. It is one of the best method to measure three-phase power. What is the commercial unit of electricity? The commercial unit of electricity is kilowatt hour, kWh. That means energy, right? Kilowatt hour. Or you can write unit. 1 unit is equal to dash kilowatt hour. 1 unit will be always equal to 1 kilowatt hour. You can note down. This is very important question. In 2 wattmeter method, it is found that 2 wattmeter reads equal. What could be the power factor of the load? Of course, the power factor of the load will be 1. This is also quite important in various type of government examination. If you are appearing for government examination, this will be really help you out. Question number 37. 1 horsepower is equal to dash watts. So 1 horsepower will be equal to 746 watts. It is the right answer. So please make a note. 1 HP will be always equal to 746 watts. Question number 38. DC generator works based on the principle of statically induced EMF, dynamically induced EMF, Fleming's left-hand thumb rule, Coulomb's law. Of course, DC generator works based on the principle of dynamically induced EMF, because you will be rotating a conductor in the magnetic field. So that is what exactly happening in case of DC generator. Basically, you can call it as it works based on the principle of Faraday's laws of electromagnetic induction. However, it is a dynamically induced EMF that is happening in case of DC generator. For the direction of magnetic field, thrust, etc., you can use Fleming's right-hand thumb rule. Question number 39. Dash component of DC generator is known as mechanical rectifier. So what is the function of rectifier? Rectifier converts AC supply into DC supply. So in case of DC generator, the commutator, what does commutator does? Commutator converts the fluctuating voltage into unidirectional voltage. Therefore, we can call the commutator in DC generator is also known as mechanical rectifier. This is very important question. Then question number 40. Dash motor is suitable for electric train. This question is one of the most important question for various competitive examination. So of course, the DC series motor, because of its the speed torque characteristics, speed current characteristics, if you check the characteristics of DC series motor, we will come to know that at the time of starting it offers high torque. Therefore, due to the important features of DC series motor, it is most viable for electric traction. Still, it is a DC motor, it is highly acceptable in case of electric traction. So you can go ahead with the DC series motor. It offers high starting torque. Question number 41. Dash electric machine is known as rotating transformer. All of you know that a transformer is a static device, but this is just like a what I can say, one special kind of question. Dash is known as rotating machine, rotating transformer. The transformer, it's a static device. It works based on the principle of Faraday's laws of electromagnetic induction, and the same thing is happening for induction motor also. So you can select option A. Induction motor also works based on the same principle of transformer, but in induction motor it is not a static device, but a transformer is a static device. That's the difference. Please do make a note. So here you have to select option A. How do you rate the transformer? Kilowatts, kilovolt ampere, kVA, or none of these. Usually transformer rated in terms of kVA because the copper loss is directly proportional to ampere rating, and core loss or iron loss, that is proportional to voltage. Therefore we have to express the rating of transformer in terms of volt ampere or kilovolt ampere. Please do select option B. Question number 43. The synchronous speed of a three-phase induction motor is given by Ns is equal to 120 F by P, where F is the supply frequency, and we are providing the three-phase supply to stator. P is the number of poles. So by using the formula, you can able to compute the synchronous speed of three-phase induction motor. This is also quite important. And the slip of induction motor can be computed by using the formula. Slip is equal to Ns minus N divided by Ns. What is Ns? Ns is known as synchronous speed. You can calculate synchronous speed by using the formula 120 F by P. Okay, N is the rotor speed. So there should be always certain value of slip, else the motor will not operate. Question number 45. Salient pole alternator has. What is the speciality of salient pole alternator? Salient pole alternator, there are projecting poles you can able to see. See, salient pole alternator will have the large diameter of rotor. Okay, large diameter and small axial length. It is not suitable for high speed application. It is suitable for very low speed application. So by considering the option, the right answer is the salient pole type alternator is having large diameter. Please select option A. For your betterment, I have shown one diagram of salient pole type alternator. Alternator is also known as synchronous generator. There are two types of alternator based on the construction of rotor: salient pole type alternator and non-salient pole type alternator. This is also quite important. Synchronous generator is also known as DC generator, AC generator, alternator, both B and C. Here you have to select option D, like AC generator and alternator. Synchronous generator is also known as AC generator and alternator. You can go ahead with option B and C. So please select option D. Question number 47. Non-salient pole type alternator has, which is the right answer? So in case of non-salient pole alternator, so salient pole we already discussed, large diameter and small axial length. In case of non-salient pole type alternator, we cannot able to see the projecting poles, and it is actually having the small diameter instead of large diameter. It is having small diameter, and also the gap between stator and rotor, that is uniform, unlike salient pole type alternator. So from this we can able to say that the non-salient pole type alternator has the small diameter, as non-salient pole type alternator will be mainly used for high speed application. That point you have to remember. Next one is dash motor is known as constant speed motor. Please do identify. Series motor, DC shunt motor, DC compound motor, both A and B. See, constant speed motor, we can select a DC shunt motor. DC shunt motor will be used as a constant speed motor, especially elevators, where the constant speed is required. You can able to go ahead with DC shunt motor. You have to inspect the speed torque characteristics or NIA characteristics, then you will understand. Question number 49. Induction motor works based on the principle of dash. See, Faraday's law, rotating magnetic field, both A and B, none of these. See, the induction motor that works based on, we can able to say Faraday's law, there is a rotating magnetic field. Phi R is equal to 1.5 into phi up we have derived already. So we can able to select both A and B. So please select option C. Option C is the proper answer. Last question for this session. The number of parallel path in the lap winding is always equal to. See, there are two type of winding in case of DC machine. One is lap winding, another is wave winding. In case of lap winding, we can able to say that the total number of poles will be equal to the number of conductors per parallel path. The total number of parallel path will be equal to number of poles. But if I talk about the wave winding, remember always, in case of wave winding, the number of parallel path will be always equal to 2. That point you have to remember. So number of parallel path will be denoted as A. So A is equal to 2 in case of wave winding and A is equal to P in case of lap winding. So this is the end of the session, and the remaining part will be continued in the upcoming session. I hope you could able to recall all the things which you already learned in the subject Basic Electrical Engineering. This is just a refreshing session so that you can able to recall, revise and analyze the things which you already studied. Let me know if you are having any queries. I am happy to answer. Ultimately, thank you very much for watching this video.